Well, thanks. I'll quickly introduce myself. My name is Matt. I'm an EV solutions engineer at Geotab. And so today, as Chris mentioned, I'm going to be walking through a bit about what our current offerings look like in terms of electric vehicle related software features, and as well expanding on some items that we're looking at bringing into our roadmap as well. So I'm just going to jump right into it, starting with kind of what we currently offer in terms of solutions for EV fleets. And today I'm going to expand upon kind of two areas within the different solutions packages we have for EV fleets. The first is the kind of going electric stage. So this is a tool set that we have for fleets that might be interested in understanding what vehicles they might be able to replace with electric vehicles, and what that would look like, how we can actually empower those vehicles to really succeed, because placement of those EVs can really be so important. And so I'll walk through kind of some of the features that we have on tools to help out on that. And then I'll talk a bit more about once we actually have those electric vehicles in our fleet, how can we leverage the data that we have to make sure that we are addressing some of the concerns that fleets might initially have when we first integrate EVs into the fleet. So in terms of going electric, here we're really talking about EV procurement and bringing in EVs in a way that we can allow them to succeed within a fleet. And so the primary tool that we have for the Go Electric stage of the electrification journey is called the EVSA, or the EV Suitability Assessment. And so this is for that early stage where fleets are saying, I'm interested in bringing in vehicles, but I'm not necessarily sure where exactly I can leverage them, if there are vehicles that are good replacements for EVs. And then if I bring in those EVs, what is that going to look like from a cost perspective? And so the EVSA has a relatively simple flow where we use the telematics data from current fleets. So if you have an entirely ICE, internal combustion engine fleet, we still have a lot of really valuable data there that we want to look at to understand the electrification potential of that fleet. So the first step is to look at that data and figure out which vehicles are range capable. And range capable is based on the electric vehicles that you might be considering bringing into your fleet. So making sure that the most that you're driving from a certain vehicle is still within that allowable range. And then once we have that subset of range capable vehicles, by default, we're only going to be displaying vehicles that are range capable, but also have a lifetime cost savings. And we'll go into a bit further detail there. That can be changed if we're just interested in more of the range capable side of things and would be willing to pay a premium to bring EVs into it. And that's something that's definitely configurable as well. But in terms of the flow of this EVSA tool, essentially the first step would be to select the vehicles that you'd be interested in assessing. So that could be the entire fleet. That could be just a subset of vehicles that might be up for replacement in the nearer future. And then there are a number of options as we start to set up the EVSA to really start to refine this model and make it more valuable. So for example, being able to choose exactly which EVs you'd be interested in bringing into your fleet, specifying if we're just looking at full-on battery electrics or plug-in hybrids as well, or even more specific, say, have a good relationship with Chevrolet and would like to be looking just at Bolts or Volts, for example, then this is something we could bring into it. And then to continue to refine the model, really add cost information. So we have default values for the procurement cost of those vehicles, but they might be different than what you're able to get them for. And then being able to add things like insurance, AV, or any EV incentives that might be available in your area. And then once we add all of this information, it's all optional, but again, it does kind of help to refine the model. We get a output. And at a very high level, it will tell you how many EVs could bring into your fleet, and what would be a battery electric vehicle, which would be a plug-in hybrid. But further than that, we'd be able to actually look at specifically which vehicles are good replacements. So if we have vehicle A, we've looked at all of the data that it has driven. We know that it's always driven less than whatever amount is range capable for that EV. And we know that based on those driving habits, we would have a total cost savings of Y. And beyond looking at those very specific examples of where we can allow EVs to thrive, we'll also have high-level metrics showing exactly what the CO2 emissions saved is going to look like over the cost of that vehicle's lifetime, as well as the total lifetime cost savings. So there's a lot of information to really be able to look through there, to be able to export this as well. We also do offer this as an API that can be configured. And additionally, this is a totally free add-in that you can get from the marketplace and be able to run right in my Geotab. So a really powerful tool that a lot of fleets really use to learn more about their electrification potential. And the next stage, once we bring in EVs and we have an understanding of where they can really be placed and where they can thrive, the next topic turns to operating with electric vehicles in the fleet. And once we bring in these electric vehicles, how can we use that data to kind of get over any potential worries that there might be if it's, the very initial stages of bringing electric vehicles into the fleet? Or if we are, seasoned vets of electric vehicles and really just want to be able to have all this data available so that we can understand the total cost of ownership of the vehicle. So when we were putting together a lot of these features within my Geotab, we kind of wanted to design them around the questions that we typically hear from fleets as they're bringing in EVs, like the typical maybe worries or any apprehensions that might be involved in bringing in EVs. And so typically a lot of the time what we're hearing, and this is regardless of the size of the fleet, it can be grouped into these main three topics, which are just how can we ensure that vehicles are getting plugged in and that they're going to be reliable assets? And then things like managing range concerns, making sure that, again, it's going to be reliable, that we're not going to have any issues in terms of range of the vehicle. And then probably the biggest point is measuring costs, making sure that with the investment that we're making into electric vehicles, are we on track to get that return? And so in terms of the options and features that we have in terms of just keeping track and making sure that vehicles are actually getting plugged in, the first and maybe the simplest is just looking at the live map. We've added within our live map, so you might be familiar with seeing this if you have any EVs, or it looks very similar with any ICE vehicles in the fleet as well. But with EVs, what we have here is the ability to see that current real-time state of charge on the vehicle. So to be able to at a glance, be able to look and know if a vehicle is fully charged, if we're going to be able to use it reliably, but also to be able to see if it's charging. So in this little snippet here, you see a little lightning bolt next to Nissan Leaf 12 and 9 there. And that indicates if the vehicle is currently charging. And so that can be one way to have to quickly look and see if a vehicle is getting plugged in. But a lot of the times, as you scale up, looking at a map isn't necessarily a sustainable way of making sure that a vehicle is plugged in. And so that's where we see that a lot of fleets might make use of the rules engine to make sure that we have a rule set up to say, for example, a vehicle is returning back to the home zone and we're seeing that the state of charge is less than 90%, to be able to offer real-time feedback to that driver to, if we have a go talk, for example, actually say a remember to plug in message, or maybe just device feedback, 2 long beeps that can be remember to plug in, or have a rule directly be sent, a notification sent to that driver saying that you're back, remember to plug in, so that the vehicle can be used reliably. And on the next piece of managing range concerns, a lot of these can kind of be similarly looked at in terms of the live map to be able to see if we are at 100% state of charge and someone is going to go out and use that vehicle to understand that they will be range capable. But one other piece of managing range concerns is just making sure that a vehicle is going to be on track for hitting that full charge. Let's say a vehicle is is plugged in overnight, and we need to make sure that it's going to be getting to 100% by the next day to make sure that we are going to be able to manage any range concerns that we might have. Well, we have the ability here, because we're getting that live power reading from the charger, to know exactly at what rate we are currently charging at, and then to know when we are going to be hitting that goal that you set. So whether that's 100% by 8 a.m. the next day, we'll be able to see at a glance if we are going to be hitting that charge target, and if we're going to be able to have adequate range for that vehicle. And then again, I mentioned probably the biggest thing that we really hear is just making sure that we're able to report on these vehicles, understand their utilization, and really be able to measure cost. And so one of the ways we have that is our fuel and EV energy report. And so in this report, we are able to compile both fuel and electric energy usage all within the same report, which can be handy if we have a mixed fleet to compare vehicles against one another, but also just to understand some high-level metrics on the utilization of that EV. So to understand if over the range of that report, they have driven 200 miles, be able to see exactly how much energy they have used, to be able to see what a energy equivalent looks like for that vehicle. And in the cases where we're bringing in our plug-in hybrids, to understand essentially what percentage of energy is coming from electric energy versus coming from fuel that is being used. And so this can be easily used to make sure that these plug-in hybrids are actually getting plugged in. Because sometimes what we might see is plug-in hybrids, if we're not keeping tabs on it, might be just used as a standard ICE vehicle and used with standard fuel. And in that case, we have a much higher TCO associated with that. And then the next is the charging report. So to be able to see at a more granular level exactly where our charges are occurring at, to be able to understand how much energy is going into them. And then what really gives us power from having that data is to do things like encouraging at-home charging, which we're seeing as kind of a continual trend. And being able to have all the information, like exact time and exact location, we're really able to further refine any kind of at-home charging model we want to put together, in case different areas might have different energy costs associated with them. And then even to take that a step further, if they might have different costs associated at different times. So again, we have a free add-in that can be downloaded to be able to set up rules such as this, and to be able to really properly track at-home charging. Okay, that is a super quick overview of some of the features that we have right now within Geotab, but now we want to look a bit about some of the items that we have on our roadmap. So this is what we're considering, pretty much really just draft solutions at this point. Although that being said, this piece here, this is the EVSA expanded EV model support. We actually just launched this. So we need to pull this into the other one, but it's happened quite recently that we were able to get this launched and good to go. And so essentially what this is the ability to, we offer a lot more potential EVs that fleets can take a look at. Because by default, what we had been doing is only looking at EV data that we were actually seeing from the field, from real vehicles that we were plugged into, to understand what that real-time range is. However, what we are offering now is the ability to run the EVSA on those EPA numbers. So this gives us the ability to look at a number more vehicles, and includes things that might not have even come to market yet. So looking at like trucks, for example, which are on a lot of people's minds right now. So we can kind of, even though we don't have the data on it, we can get ahead of that and start running these reports and understand if we would be able to integrate those into our fleet. So with that, we added over 120 EV models. And so this is a really exciting way of, like I said, kind of getting ahead of that, even if we don't have the vehicles in market, still be able to start planning for them. The next piece is kind of an extension of the EVSA as well, and this is related to a charging infrastructure planning component. So another huge topic right now is just making sure that when we start to bring in electric vehicles, that we have charging infrastructure in place to be able to support them. And again, we have valuable data here that can be used to make some give information on the charging infrastructure side of things, particularly in terms of dwell time. So simply just where are vehicles typically being parked at for long periods of times, whether that be overnight or if there's times in the day. And then also to use that time that we know they are going to be parked at that home domicile to know what type of charging they would require. If that's going to be the level 1 charger, and that might be fine for that vehicle, or if we're going to need a level 2 charger. So the next piece, and I believe I saw a comment on this right before I kicked off presenting, is actually looking at the EV battery state of health. So we know that we do see degradation in EVs. It's relatively minor. We're seeing it in the field around 2% a year. But to have the ability to actually look at specific vehicles and understand what the EV battery health is for that vehicle, if it is essentially on par with other vehicles in the field, seeing around that 2% degradation, or if it's anything different, what are the factors that might be changing that degradation rate for that specific vehicle? So are we seeing that we're only fast charging that vehicle like every day, because that can result in some faster degradation if we're using fast charging a lot. Things like climate, things like age of vehicle, to be able to better understand what that battery health really is. The next is the EV range capability. So to understand particularly the impact on temperature. So we know that there is a relatively large correlation between range and temperature. So this tool will help understand exactly what that is in your environment, and to look back at, say, the last 12 months and figure out what that real-time range is as we've seen fluctuations with temperature. And then the next step from this piece of the EV range, kind of looking backward and seeing what the range capability is to have a real-time range, where essentially this would be an extended feature on the live map that would include range information, real-time range information of that vehicle that's based on the current state of charge, and then understanding its historic range in that, that temperature zone. So this again would help with any fleet that might be interested in making sure that a vehicle is going to be range capable, to understand the kind of best and worst case range based on that condition and the current state of charge. And so again, that's a bit of what we're looking at right now in terms of some of the roadmap items. Again, went through that quite quickly, but I'm definitely very interested in hearing feedback and would love to hear any questions that we might have on either the roadmap items or on any of the current solutions that we've walked through.
That was great. Thanks a lot, Matt. But certainly very informative to see what is currently available and what is on the dev roadmap. I did see you did handle the one question of is battery health monitoring in the roadmap? So that was good. Thank you. I had a couple come into me kind of on the side here. One of them is, do you integrate with charging stations to see which stations are available within the yard?
Yeah, so we do have charging station integration. The primary purpose that's and like a big value add that we can add as Geotab and giving this data to charging stations is to offer real-time state of charge, because when you plug in a charger to a vehicle, that's not information that's necessarily known to the charger. So when doing things, down the road, brought in a bunch of EVs, maybe looking at doing something like integrating smart charging into the fleet, to be able to have the integrations that we have with our charging stations to give them this data, it enables them to do things like prioritize charge of certain vehicles if they have lower state of charge and we know that they need to get used for the next day. So there's a lot of really exciting potential in that space. And yes, we are working with a variety of charging station and supply equipment OEMs.
Perfect, thank you. And then in terms of the battery degradation, are there any rule sets that would be able to be applied to that to flag anything to say this one is below X percent, might be time to swap it out or change it out?
So that's a really interesting point. I'm not entirely sure if we will have something built out in terms of like a rule, mostly because it occurs quite slowly. It's not really a thing that all of a sudden it might pop up and say, oh, you need to, replace it, but more so with monitoring and seeing the trends once we dip below, a certain amount, and obviously that'll change quite a bit fleet to fleet. With that monitoring, they'd be able to make those decisions. However, that's a really interesting point and something that might take to one of our product leads. One thing that I will mention in terms of where rules might be really beneficial is in looking at some of the factors that contribute to that battery degradation. So if we know that vehicles are being charged DC a lot, if we know that they're being driven, we're seeing a lot of fast accelerations and things that might be maybe a bit more taxing on the battery, we can alert and monitor these events to be able to kind of better control the degradation that we're seeing.
That's very interesting stuff. Great data to have. So one last question here. How many make and models then does Geotab currently support? And what is kind of the estimated number that you'll be bringing on for 2022?
Yeah, another awesome question. So right now we are sitting at 188 EV different models that we are supporting. And that's something that we're really proud of, mostly because the support for electric vehicles looks a bit different than it does for our ICE vehicles. With ICE vehicles, there's set protocols where we know exactly where we could find certain data when we plug it in, where we don't really have that for EVs. It takes a lot of reverse engineering. So we have dedicated teams where all they're doing is making sure that we're able to support models as they come to market and be able to give this rich data back to the fleets. So right now we're at 188. We are hoping to hit 200 in the November, December kind of time period. And then moving forward into 2022, we haven't had that larger discussion on, what our goal will be. Like for example, our goal this year was around 200. We added 100 EVs just this year. So moving forward into next year, I'd say we'd be looking to do the same, but it could even scale up because we're seeing so many new electric vehicles come to market. It's really exciting.
Yeah, definitely. And then I imagine as the OEMs start to roll out the light duty pickups and so on, that number is really going to ramp up, and especially as the demand really increases on your side for that type of information. Right?
Yeah, exactly.
Well, that's all the questions that we have. So I want to thank you very much for your time today, Matt. This was certainly very informative. I do know we've got some customers on that have got quite a few EV orders in place. One's got about 50. So this is certainly something that is very close to their interest level right now. So thank you very much again for your time. This was very, very informative. And thank you to everybody who participated today, and have a wonderful day and rest of your week.